Hi, everyone. This is Saad Ode. I am your unit coordinator for Eng 150, Fundamentals of Engineering Studies. This video specifically for those who missed the first week lecture. So I will go through the main topics in this lecture, so you'll be able to follow up with other students. First of all, I would like to go through the main things that you need to look at in the website. So you will find out the website if you click on your Moodle or your link to the website main page will look like this one. So if you scroll down, you will find different tiles starting from the information about the course, about the unit, type of assessments, how to link online through Zoom, and also a welcome message here and some information about the unit. So if you like to, let's say, click on information here, it will give you subtiles here for the learning schedule, when like in each week what we're gonna study, and also the timetable for your unit, what time and on which day. Essential readings, there are some few books here listed in this page, so you can go through it, and if you like to borrow the book from the library or buy the book, you are most welcome. Also, the Eng 150 unit guide. In this unit guide, you have comprehensive information about the unit, the type of the workload, the learning outcomes, and all other information, the weekly schedule, and the type of assessment that you will have. So basically, this is the what you need to know from this tile, also in the type of assessment. And here you can find the link. If you want to link to the online, to the class online, just click on this and you will be able to link online. Also, you will have the unit material. So all the lecture materials, the tutorial materials in each week, like week by week. So if you look at these, like week 1, week 2, week 3, and so on until week 13. So if you click, let's say click on week 1, you will have the learning outcome of that week, and also you will have the slides for that week, some tutorial, some class quizzes, and also for those who missed the first week, you will find extra information in this section of the page. So really, it's have a lot of information here. If you follow this, you will be able to pass the unit. This unit, Eng 150, is a design-based unit, or they call it capstone unit. So you will be able or you will be introduced actually to design a simple system in engineering using the information that you acquired during the session, and as well as during the previous semesters. So if you look to this page, you'll find we have 5 major assessments, but the most important 2 assessments is the design project. It has 40% weight. This design project will be along 6 or 7 weeks of the course, and the final exam has 30%. So if you don't pass the design project, which is most of you don't pass it if they come to the class, and also if they interact with the teacher and submit their final report, and also the final exam. Both of them, if you attend them and attempt them, you will be able to pass the unit. So please make sure that you come to the class, interact with other students and with your teacher, so you'll be able to submit your final project report and pass the unit. This unit, Eng 150, introduces you to the principles of mechanics, or they call it statics, and which has wide application in engineering systems, such as you can see in this slide, structural engineering, heavy-duty machine designer, even electrical motor engineer, because you need to know the forces. You need to know the force analysis of this kind of motors, robotics, aircraft, as well as electronic and computerized devices design. So this is actually, you can see it's has wide range of application. Every single engineering major requires statics and principle of mechanics in order to design the right system. Before studying this unit, you need to be aware of a few terms and principles. The first one, for example, here, the difference between rigid body and deformable body. So most likely in our current study, we will work with rigid body, which is a body when the change in distance between any two of its spots, it's negligible. So when you apply a force on any body, it will not change the size or the length of this body. Also, you need to be aware of some the important units, SI units. I believe everyone knows this from previous units, or especially if you study physics. The other thing here is you need to know the trigonometry principles, such as the right angle triangle principle and non-right angle triangle. This is the Pythagoras principles. I believe everyone should know this from previous study in maths, as well as the sine rule and cosine rule. So please, if you don't, or if you forgot these, you need to revise these principles importantly, because you will not be able to proceed in the force analysis without having these information. So, for example, here we call this triangle a right angle triangle because we have this angle here. It's the angle normal to the horizontal line is 90 degrees. So this is 90 degrees, and because of this angle, we call this triangle is it's a right angle triangle. And if we have right angle triangle, then we apply Pythagoras rule. And in this rule, you can easily, let's say, for example, if you want to find the angle theta here, so we say sine theta, the opposite side, which is this side, the y-axis, we have y and x-axis. So in these two axes, we have we can say that opposite to the theta is the b or y axis, and adjacent to theta is the x-axis, the a length. And then if you want to find sine theta, you say simply the opposite side divided by hypotenuse side, which is the length, the longest side in the triangle. So we can say opposite side here, B, divided by the hypotenuse, which is, we call it, let's say, for example, call it L. So if I divide by L, so B divided by L will give you sine theta, and so on. Similarly, for the non-right triangle, in non-right triangle, none of these angle is 90, and therefore, if none of them is 90, then we call it non-right angle triangle. And we have different rules here. We have, we call it what we call sine rule. This is the first one. It's simply you divide the length opposite to each angle, divide by its sine. So for example, the first one, A, the length A, divide by the sine A, the angle A. This is angle A. And for length B, we divide it by the angle B, sine B. So this is B divided by sine B, and so on. The third one, C, the length C divided by the angle sine C. So if you have any unknown, either angle or length, you can simply substitute this in this rule. Also, for the same triangle, non-right angle triangle, you can apply what we call cosine rule. So in cosine rule, you have to have at least two lengths available. For example, here, if you have length C and length B, and you know the angle A, then to find A, the length A, you can apply the first equation. So you can say A squared is equal to B squared, because B already known, plus C squared, which is also known, minus 2BC cosine A, because A already given. So if we put it under root and the square root, you can find the value of A, and so on for other lengths, B and C. So you can apply the same rule for each length and find the unknown length or unknown angle of that triangle. There are other rules that you need to be aware of, or you need to revise from previous math units. Such as the angles in the parallelogram, the total angle of parallelogram, which is like 360. Actually, also each two angles opposing each other, they have the same degree. Let's say here B and D, they have the same value, same angle. A and C also, they have the same angle. Also, the other, of course, the corresponding and alternate and co-interior angles. For example, if you have two parallel lines and then another line crossing these two lines, A and B, the angles A and B, they are the same, so they have the same values. The alternate one, X and Y, also they have the same angles, and also the co-interior angles R plus S should give you the same 180 degree total angle. So if you know, you say the angle R and you don't know S, so you say 800 degree, 180 degree minus R will give you S. So these really from previous studies, you need to revise it before you start this unit. We have few examples in the lecture notes available in the website. So please go through these examples just to practice and remember these rules. It's quite important. It's very simple, but you need to be aware of these rules before you start mechanics or statics. The other thing that you need to know is the vectors. A vector is any physical quantity that requires both magnitude and direction for its complete description. You can say, let's say, a force value is 10 kilonewton, and that without mentioning the direction. Otherwise, doesn't mean anything for us. Doesn't help us. We need to know the direction of the force as well as the value of the force. There will be, like always, you need the vector sum or this subtraction of the vectors. So the resultant of the vector, if you have, let's say, two vectors, V1 and V2, they are in this layout. So let's say the vector v1 and then other force um, v2. The resultant of these two forces is simply the connection between the tail of the first force v1 with the head of the force v2. So if you connect them with a line, the line here s, and I measure the line, I know the value of the resultant of these two forces. You can describe this or show this graphically. So if you have a graph paper and you can draw these forces on the graph paper, and you can find the length of the resultant force by connecting the head and tail of these two forces, and then find the resultant of the force. There is a site you can practice this actually using this link. I will show you quickly this site or simulation site for the vectors. So if you click on this link here, you will go to this simulation site, and then it will allow you to draw the vectors here. I'll show you now. This is the, for example, I'll take 2D vectors, and if I click on this and I have this graph paper, I can choose the vector from here, from the right side. So if I pull this to this, for example, I know the length of this vector. For example, here it's 10 units, the length of this vector 10 units. I have other vectors, for example, b. I bring this vector here, and for example, this vector also give it a length, for example, 7.1 units. If I want to find the resultant of these two forces, or to these vectors, simply I bring the C here, I pull the tail of the C, pull it toward the tail of A, and then connect the head of C with the head of B, the force B. And then I can find the result. I click on the C now, it can read, it can show you the length or the resultant of these two forces, which is 15.8. Also can show you the angle between C and the x-axis and so on. So I really strongly recommend you to go to this website and try to practice this yourself. Other way to find the resultant of two vectors or more than two vectors is by using the parallelogram method that we mentioned previously in previous slides. So you can apply the sine or cosine rules. If you have, let's say, for example, here, vector v1, this is the v1, and vector v2, which is the other one here, which is unknown here. If I have v2, then v2 is 3 units and v1 is 4 units. I want to find the resultants. So what you need to do is actually just to complete the parallelogram by connecting these, by drawing parallel to each vector and close the whole parallelogram. The diagonal of this, which is the S, the diagonal of the parallelogram represents the resultant force. So when I complete the parallelogram and draw the diagonal, I will have two triangles here. From these two triangles, I can apply cosine rule or sine rule and find the unknown length or the unknown angle. What you need to do actually here, if you do some practice, in the next slide, you have some practice here. Please go through this example in the slides. So go in the website and find the slides of this lecture, the complete slides, and then try to practice this. So I will go through it quickly here. As we said, we have V1, which is 4 units, and we have V2, which is 3 units. We say 3 units because we don't want to give you any value. Let's say it's, if you want to have if you have a force, then it's 4 Newton or 4 kilonewton. All right. If you have, let's say, if you have different vector, different values of the vector, then you put the units of that uh, vector. But for most our application will be forces. So we'll use the force, which is either Newton or kilonewton. So if I say 4 kilonewton and 3 kilonewton forces, I need to find the resultant S. So this is S. So how to do it? As we said before, we complete the parallelogram. I will draw a line from parallel to the force V2 and also another line parallel to the force V1. I complete the parallelogram, and then once I have this parallelogram, all these angles are known. So I have the angle here 105. This is like a triangle. If I draw it here, it will be like this. This is S, and we have the force V2, and the force here, the other one, force V1. The angle between them is 105, which is not 90 degrees, and this will help us to know that which um, theory or which principle we apply. So here we can't apply Pythagoras rule because we don't have 90-degree angle. We apply the sine rule and cosine rule. So as you can see here, we applied to find S, the value S here, I apply the cosine rule. So I know the first force 3, the second force 4, and then 2 times 3 times 4, and then the cosine theta, which is the angle between two forces, V1 and V2, which is 105, 105 degrees. And then when I solve this, I can find the resultant for these two forces. If you want to find the angle, same thing, you apply sine rule, and you can find the alpha angle. So you apply the sine rule, you have two sides, you know to the two sides, and you know their angles. One and the angle is unknown, so you can say sine 105, which is given, divided by the resultant, which is already found. This is the resultant. We can use the value here. And then sine 30 plus alpha, which is because alpha is unknown. This is the angle here I want to find. So this angle divided by the opposite force, which is V1, which is 4 Newton, all right? So these two, these are available. The only unknown is alpha. So if I solve the equation, I can say sine alpha plus 30 equal 0.692, or I can say the alpha plus 30 is equal to sine inverse. The value 0.6, sine inverse 0.6. 692. So and then I solve this, I can find alpha value. All right. So I hope this video give you a brief information about the first lecture and what you need to know and what you need to revise before starting studying the coming topics from week 2. So please go through the lecture notes given in Moodle in your website, and do not miss any information, because this is the foundation for the coming weeks. I hope you will do well in this unit and progress very well and pass the unit. Thank you.